All right, we are moving on to volume 2 of our Ready Math series, and you will no longer need your first book. We're just going to strictly work with the second book. And we left off with fractions and mixed numbers with book 1, and with volume 2 here, we're going to go to working with decimals again. And today's focus is taking decimals and multiplying them by a whole number. So for a warm-up, I just want to use this just to show, again, the connection between multiplication and addition. Multiplication is basically a quick way to add multiple numbers together in just one step. So here's our example. So you have a tower of blocks, has 3 layers, and each layer has 8 blocks. So let's pretend this is our tower, and it's got 3 layers, and I've got 8 blocks in each layer. So we could do that one of 2 ways. We could just do layer 1 is 8, layer 2 is 8, and layer 3 is 8. And add those up. I know 8 plus 8 is 16. 16 plus 8 is 24. Or the quick way is you've got 3 layers, 8 in each layer, so just multiply, and you'll get the same answer, just with fewer steps. So this lesson isn't to say that multiplication is better, as much as it's to show you it's quicker and a little more efficient and less room for error, because you're just, again, taking these 2 numbers and multiplying them. When you start adding multiple numbers, it gets kind of tricky. Sometimes we might even lose our place and forget to add or add one extra. So multiplication is just probably the best way to go. So check out page 309, and you should see these multicolored tiles at the very top. I don't have the fortune of having that on this slide, so I'm going to have to create my own, poorly, of course. So here's mine. Get rid of that right there. And let's make, and I've got 6 different blocks or different tiles here. So let's read up on this problem. So Margot has 6 square tiles of equal size. So we'll assume mine are all equal. Each side of each tile is 0.8 inches long. So I'm just going to write these in. So basically what they're saying is the measurement of this one side on each part is 0.8. So all those slides are touching and they're in a row. And how long is the row of tiles? So they want to know this total distance from end to end. So you could do this, like I said, with our warm-up, do a couple different ways. First way you could do it is take all of these decimals and add them up together. 1, 2, 3, 4, 5, and let's add one more for 6. And I'm just going to put a question mark there. I do know the answer, but I want to show you what, because we could go 8 tenths plus 8 tenths is 16, plus 8 is 24. We could have 30, 36, and 48, 48 tenths. Or you know that there's 6 tiles, and each is the same length, which is important, because that means we can do that. And we could do 6 times 8. We can multiply these numbers to give us 48. However, since we're multiplying, our 8 is actually 8 tenths, we have to put a decimal point in between them. So 4.8, 4.8 inches. So because we're doing just whole numbers by a decimal, where we place a decimal will be fairly simple for the first couple lessons. If you're multiplying by a tenth, then that's where your decimal point has to go. And you'll see as we move on to some other examples. Okay, so go ahead and turn the page. And I'll do the same. So number 1 here, explain how you found the length of the row of tiles. So basically what we did, we multiplied 0.8 by 6. And it gave us, remember, the answer to a multiplication problem is a product, so that gave us a product. And here's part 2. And this kind of just shows you what happens when you are multiplying by different place values. You can find the length of the row of tiles through repeated addition or multiplication of a decimal by a whole number. Look for the patterns in the factors and products when multiplying with the whole numbers and decimals shown below. So remember, the numbers we multiply are the factors, and the answer is the product. So this one's pretty simple. 2 times 3 is 6. So I've got 1, 2, 3, 4, 5, 6. This is 2 times 0.3. So that will give us 6/10. So basically I've got 1, 2, 3, 4, 5, 6. 6 out of 10, or 6/10. And this is 2 times 300ths, which gives us 0.06. Because it's 1, 2, 3, 4, 5, 6. That's 6 out of 100. So 600, 6/10, and 6 whole. This is basically, this one over here, it just would be the 6 wholes. So again, pay attention to the place value of what you're multiplying by, and then your answer will be the same when we're dealing with whole numbers. And let's look at this last part. What patterns do you see in the factors and products in the equations? How are they reflected in the model? So this is what we want to say. I'm going to say that the value of the product and by value we mean the place value. So in this particular case, with what we're looking at above, the value of the product changes from 3 ones to 3/10. And 300ths. Okay, and that just kind of illustrates what we're doing happening up there. All right, because this is the first session, it's very short, so I really just want to get you right into practicing this stuff. So you go to IXL, it'll be I5, multiply a decimal by a 1-digit whole number using blocks. That will look somewhat like this. So the reason the blocks are here is because you can add them up, for example, to get your answer. Like for this one, I've got 3 times 0.23. So I know if I do 3 times 23, that'll be 69. I've got those two. So the answer would be 69/100ths. And if you count this up, I've got 1, 2, 3, 4, 5, 6, 6/10. And these cubes are hundredths. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 900ths. So that's what's represented with the blocks. And that will get me my answer. So if you have any questions, just let me know, and I'll help you out.